I've had some questions about two-sided hypothesis tests, so I wanted to take a moment to clarify some of these questions. All right, so you notice I wrote two-sided test. I gave us a significance level of 5%. So essentially what that means is we are basing our null on a parameter that we assume to be happening. We assume to see this parameter. So I can put that right here in the middle. Now that parameter might be mu, might be p. Again, we're building something off of an assumed parameter. Now for two-sided tests, that means we'd be discounting values that are too high and values that are too low. So in this range right here, I'm going to color this in brown. If we see statistics that fall into this range here, like if we do it, if we go in assuming a parameter, then we get a statistic, and it falls in here, then that would support our null. Now again, we don't accept the null, but we would fail to reject it if we found something in here. Even if we ended up getting, like, say, we're doing a test based on proportion. Say we ended up getting one way out here. Still, it's not likely, but it could happen. So if we get a statistic way out here, probably not likely to happen based on this parameter, but it could still happen. Now, if it's a two-sided test, what that is telling us is that if we find a statistic that falls in this 5% or this 5%, at that point, we can disprove our null. So maybe we get a p-hat somewhere out here. Maybe we get a p-hat that's really low, somewhere out here. As long as it's in this lower or upper 5%, that would be enough evidence for us to disprove our null or reject it. Now the thing with a two-sided test is, that means you'd only be accepting 90% of your statistics. Or say you have a one-sided test. I'll shrink this down so I have a little more space. Let me shrink this down. Well, say I have myself a one-sided test, right? In that case, again, normal distribution, just like so. I'll put one-sided here. Say it was a one-sided test. Like, say it was based on, I'll use mu this time. Like, our null would be mu equals something. Like, we'll say 4. And then maybe our alternate is, now if this were one-sided, that means our mu could be greater or less. So we'll go with greater in this case. It's going to be greater than 4. So then I would just build a distribution based on 4 being my parameter. Now you notice we have two ends here. Now if it's one-sided, right, that means we are only concerned with one side, the side that's greater. So we are concerned with the 5% that would be greater in this case. So in this case we have 5%. And I realized I probably used the wrong value. Oh, yep, I did. Should put a 0 here. Whoops, no biggie. Because we're concerned with this 5%, which means if we get anything in here, that's enough evidence where we wouldn't necessarily reject our null. It'd have to fall within this upper 5% in order for us to reject the null. So that means in this case, 95% of our possible statistics would work in favor of our null hypothesis. 95. So I guess you could almost call that an advantage or a disadvantage, however you'd want to approach it, because with a two-sided test, only 90% of our statistics would validate our null hypothesis. Whereas with a one-sided test, only we'd have a whole 95% that would support our null. So you have more data or more possible statistics that would support your null hypothesis here, whereas up here for your two-sided test, you only have 90% of your possible statistics. What to pull from this? It simplifies things a bit. That means whenever you're doing one of these tests, if you get a p-value, the probability of seeing your statistic, you get a p-value that is less than 5%, that means we reject our null. Regardless of whether it's one-sided or two-sided, anytime your p-value is less than 5%, you would reject your null hypothesis, which means you would accept your alternate. I just wanted to walk through that because I've had a few questions. Hopefully this helps.